mainan beraber. Kelas lagi video.
Good evening, students.
Good evening,
Good
sir.
evening.
Good evening, beta. So in the last class, I was discussing moment of inertia. Moment of inertia. So if a particle, single particle, is rotating about an axis in a circle of radius r, like this. This is the particle, it is rotating like this in a circle of radius r. Its mass is m and it is rotating like this. Then what will be the moment of inertia of this particle? That will be I equal to, okay, mr square. This will be mr square. If more than one particle are rotating, suppose second particle is this, but all the particles are rotating with the same angular velocity. This is second particle. Suppose this is mass is m2. This is m1 r1. Radius is r2. And suppose many particles are here. Then what will be the moment of inertia of the system? That will be m1. You can say r1 square plus for the second particle, this will be m2 r2 square. And if more particles are there, it will be like this. So what will be the moment of inertia of this system of system of discrete particles about the same axis, and they are rotating with the same angular velocity omega. So this will be sigma mi, you can say ri square. This will be I. So if you are having a discrete number of particles and all the particles are rotating on the circular path around this axis, you can assume it as z cap axis, okay, with the same angular velocity, then moment of inertia will be given by this. if in place of this discrete particles, you are having a rigid body, and that rigid body, ठीक है, that is made up of continuous distribution of mass, then for moment of inertia, you will use this formula. For continuous distribution of mass, you will use r square dm. ठीक है? For the complete body, you are going to integrate. So this will be the formula for moment of inertia. For the moment of inertia. Next, what is the moment of inertia of a ring? If you are having a ring like this of radius r, mass m. So this is a ring of radius r and mass is m. If this ring is, if you want to find out moment of inertia of the ring about this axis, it is rotating like this. Okay? Then what will be the, this will be a symmetrical structure. Each and every particle is at the same distance from the axis at a distance r. Every particle is at the same distance here. So for every particle of this ring, moment of inertia will be mr square. So what will be the moment of inertia for this? This will be sigma mi. Here I am considering all the particles whose number will be in nearly infinite. This will be r square. So for the ring, this will be mr square. For the ring, this will be mr square. Okay? After that, we find out the moment of inertia of a disk. For a disk, if you are having a disk like this, and this is a disk, and you are rotating this disk about this axis, passing through its center like this and perpendicular to its plane. So this is a disk. If mass of the disk is m and radius of the disk is r, then what will be the moment of inertia of this I? That will be 1 by 2 mr square. mr square. ठीक है? This disk is made up of two equal parts. So on the basis of this, we find out if you are having a half disk like this, you are having a half disk and it is rotating about this axis passing through this point C here like this. It is rotating about this. Then on rotating, what type of structure it is going to create? It will create a symmetrical same two-dimensional structure. This is a two-dimensional structure, and on rotating, it is going to create a two-dimensional structure, that is disk. So formula for this will remain same. So if mass of this half disk is m and radius is r, then formula will remain same. That will be 1 by 2 mr square. This will be. Now suppose you are having a sector of this. If you are having a sector of it, suppose this angle may be 10 degree, 20 degree or any. So this is a planar body. If you consider an axis that is perpendicular to its plane. So try to understand, this is a small part of the disk. Radius is r. And it is rotating about this point O. So on rotating, it is going to create again symmetrical structure. This is a two-dimensional structure. Disk will also be two-dimensional structure. So formula of moment of inertia will be same. So that will be I. Suppose mass of it is m. So it will be 1 by 2 mr square. So formula will remain same, but always remember here m is the mass of the disk. Here capital M is the mass of half disk. Here m is the mass of this section, small section. But remember this, why formula remains same? Because this is a all the three, they are two-dimensional structure, and on rotation they are also creating a two-dimensional structure, symmetrical structure, that is disk. ठीक है ना, that is disk. So formula remains same, mass changes. Here mass is of this disk, here mass is of this half disk, here m is the mass of this small section of the disk. So it will be like this. After this, I have discussed parallel axis theorem. So what parallel axis theorem says, that it says that if if this is a road, I have taken the example of road in the last class. If this is a road, so there will be its center of mass that will be at the center of it. So at this point, at the center of the road, there will be center of mass. So here, this is an axis that is perpendicular to this road. So this is a road here. This is a road. Its length, you can say this is L here, this is L here. So length is 2L. So what is the length of this? That is 2L. 2L is the length. What is the mass? I'm choosing its mass is M. So what I'm saying, if this is an axis that is perpendicular to this road. So ये क्या है? This is an axis that is perpendicular to the road and it is passing through its center of mass. Then on rotating this road about this axis, you will get some moment of inertia that will be IC. What do you call it? You call its moment of inertia IC. So the axis that is passing through the center of mass, ठीक है ना, moment of inertia corresponding to that axis will be IC. You are rotating this in this way. This is a 1D structure, and what it is creating, it is creating 2D structure. So suppose its moment of inertia is IC here. This is IC. So IC वैसे कितना होता है? I'm going to tell you. It will be M, length of the road. Length is 2L. ML is square upon 12. In the last class, I have taken the length of the road as L. So that you can understand, this time I'm taking this example with 2L length. Now you want to find out its moment of inertia about this axis. So one thing is, if you want to apply theorem of parallel axis or parallel axis theorem for moment of inertia, then these two axes, they should be parallel to each other. So first condition is axes should be parallel. ठीक है ना, parallel axis होना चाहिए. Axes should be parallel. Second, one of the axis, ठीक है. Second thing is one of the axis should pass through the center of mass. Should pass through the center of mass. Through, this is important. It should pass through the center of mass. So you will be aware about this IC. In this case, if they are parallel and this axis is passing through the center of mass, then moment of inertia about this axis means if you are rotating this road about this axis, then this I will be given by IC plus mass of the road and this distance separation, perpendicular separation between these two axes is, suppose this is x, so this will be mx square. So according to parallel axis theorem, moment of inertia about an axis, moment of inertia of an object about an axis will be parallel to the sum of the moment of inertia of an axis that is passing through the center of mass and parallel to this one. So passing through the center of mass and parallel to this axis plus mass of the object, mass of this body multiplied by x square, where x is the perpendicular separation between these two axes. Perpendicular separation between two axes. So basically, this is called as parallel axis theorem. What do you call it? You call it as parallel axis theorem. Parallel axis theorem. And this theorem is applicable for all type of bodies. You can apply it for 1D bodies, 2D bodies, 3 bodies, 3D bodies. You can apply it anywhere. You can apply this anywhere. So this is called as parallel axis theorem. This is the first theorem related to moment of inertia. Now go for second theorem, perpendicular axis theorem. Perpendicular axis theorem. First thing that you have to remember about this, This will be for a 2D bodies. This will be applicable for a planar bodies. ठीक है ना? Planar bodies, laminar bodies, ठीक है, और 2D bodies. For example, you can apply this for the ring. Ring is a two-dimensional structure. ठीक है, you can apply this for disk. You can apply for rectangular plates. Etc. So basically you can apply this perpendicular axis theorem for two-dimensional bodies, planar bodies, or you like a disk, ठीक है, rectangular laminas. So for this type of bodies you can apply. You cannot apply this for 3D bodies. Remember this. You cannot apply for 1D and 3D bodies. It can be applicable only for 2D bodies. ठीक है ना? So this is one of the most important aspect of this perpendicular axis theorem. Now what this theorem says? This theorem says that if I consider uh, if I consider a just once if I consider a disk like this, and consider here this is a two-dimensional body. I am saying this is a disk. This is a disk here, and here you consider two perpendicular axes. One of the perpendicular axis is this, and second one is this. They are two perpendicular axes. Hello. Second is this. They are perpendicular to each other. ठीक है ना? So this is they are two perpendicular. This is x. Suppose this is y. ठीक है? So here I am considering two perpendicular axes. They are at 90 degree. One is, I can assume one is x-axis, another is y-axis. Suppose you rotate this, disk about this axis. Then what you are going to have, you will have a symmetrical structure. What type of symmetrical structure you will have? 3D sphere. You will have a spherical structure. On rotating this about this x-axis, what you are going to get, you will have a sphere. And suppose moment of inertia about this axis is Ix. Now you rotate this disk about this y-axis. On rotating this disk about the y-axis, what you are going to get? Again, you are going to get the same type of sphere. So moment of inertia about x-axis and y-axis, they will be same. ठीक है ना? They will be same because they are finding identical type of 3D structure sphere, same type of sphere. Either you are rotating it about x-axis or you are rotating it about y-axis. On rotation, you are going to get a symmetrical structure, sphere. Same type of sphere you are getting. So due to symmetry, you can say Ix and Iy, they will be equal. Here in this case, Ix and Iy will be equal. ठीक है? So what I am saying, suppose you are choosing two axes which are lying in the plane of this laminar body, two-dimensional body, Ix and Iy. Here, this is x-axis, y-axis, two perpendicular axes. They are lying in the plane of the body. Then sum of these two moment of inertia, Ix plus Iy. Moment of inertia of this body about these two perpendicular axes lying in the same plane, ठीक है? Here this sum will be equal to, किसके equal होगा? You are going to consider a axis that is perpendicular to the plane of the body. See, ठीक है? This axis should be perpendicular to the plane of the body, first thing. And this axis, third axis, this should pass through the intersection of these earlier two considered axes. So first two axes is they should be perpendicular. So what are the rule? These two axes, first two axes, they should be perpendicular to each other as well as they should lie in the plane of this body. ठीक है ना? They should lie in the plane of the body. And Where will be the third axis? Third axis should pass through the intersecting point of these two axes. This point is suppose O. So third axis is passing through the intersecting points of x-axis and y-axis, and this third axis will be perpendicular to the planar body. ठीक है ना? Whatever is the plane of the body, this disc, suppose here this is a disc, so it should be perpendicular to the plane of the disc. ठीक है? So suppose moment of inertia about this on rotating this disk about this axis, z axis, suppose that is Iz, then sum of Ix plus Iy, that will be Iz. So this will be Iz. So what is important here? First, two axes, two mutually perpendicular axes. Two mutually perpendicular axes lying in the plane of the 2D body. Lying in the plane of the body. Of the body. First, we are going to choose these two. If you want to apply this perpendicular axis theorem, so first you have to find out two axes which are mutually perpendicular and they are plane of the body. Okay. Second, you are going to choose a third axis. So third axis should be should be perpendicular. It should be perpendicular to the plane of the body. Perpendicular to the plane of the body. Plane of the body. And it is passing and it is passing through the intersecting point, through the intersecting point. So three axes you are going to choose. So here, example of this I have taken as x and y axis. So here x and y axes I have chosen. So in this example, x and y axes are like this. And third axis that is passing through the intersecting point O and perpendicular to its plane, that is z-axis. Z-axis. If this type of situation you are creating, then you can apply this Ix plus Iy. It will always be equal to this Iz. ठीक है ना? Ix plus Iy, this will be equal to Iz. So this is the way you are going to apply this perpendicular axis theorem. Next question will be either this intersecting point. There may be a question about this, that where this intersecting point should be. It can be anywhere. Remember this. Okay, it can be anywhere. It's not necessary it will be at the center. It can be at this point also. This theorem is applicable, but third axis, which is perpendicular to the plane, okay, that should pass through the intersecting point. So it's not necessary that I'm going to choose this here. Okay, na? This axis and they are intersect. No, it can be here also. You can choose this intersecting point here also. Even then it is applicable. So intersecting point is not necessary the center of mass. So it is not necessary. It is not necessary necessary that that intersecting point is center of mass. It can be anywhere. ठीक है ना? You can choose it anywhere. You can choose it anywhere. Is it clear? Hello?
Yes, sir.
Yes,
Sir,
sir.
Okay, okay, beta. Okay.
sir,
Yes, beta, please.
सर कोई भी आर्बिट्ररी डायरेक्शन में अगर सेंटर ऑफ सॉरी मोमेंट ऑफ इनर्शिया निकालने बोले तो उस टाइम में क्या करेंगे?
For the in the arbitrary direction, we will deal it later. First, we have to find out. You can find out moment of inertia about an arbitrary direction. It's possible, but for that purpose, first you have to find out moment of inertia tensor. First, we will write moment of inertia tensor, and after writing that, you can calculate about any arbitrary direction. You can choose whatever direction you want to choose. You can find out. So that will be the second step. Right now, I'm considering only those axes, ठीक है ना, about which if you are rotating the object, you are getting a symmetrical type of structure. Remember this, in every case, wherever you are considering, you will consider only those axes about which if you are rotating the object or rigid body, you are getting symmetrical type of structure. This type of axis is actually, they are called as principal
Principal
axes. So later on, we will modify it. We will further investigate this aspect. But right now, we are just learning the basic aspects of the moment of inertia. So, but you can choose any axis. I can choose that arbitrary axis like this. Okay? Suppose I can choose this axis. You can also find out about this axis if you rotate. Suppose this angle is theta. And you are rotating about this, I can find out. But for this purpose, first I have to write moment of inertia tensor. ठीक है, first I will write moment of inertia tensor. I will explain you everything, so don't worry.
So,
Yes, beta, please.
so how to find the direction of moment of inertia?
How to find the direction of moment of inertia? ठीक है, moment of inertia, बोलो बेटा, this is a scalar quantity or scalar quantity or a vector quantity, or what type of quantity is?
sir,
Actually,
tensor.
it is a tensor. So its direction will not be like this. It will be a tensor quantity. ठीक है, तो ऐसे direction नहीं होगा बेटा इसका. So that's why I was saying this is a tensor quantity. So next beta. So this was perpendicular axis theorem. Now come back to this disk. Come back to the disk. So I have explained you perpendicular axis theorem. Now you know that we have yes beta, please.
सर वो लास्ट पॉइंट जो है सर उसमें एक डाउट था
Yes beta, बोलिए please. बोलो बेटा.
सर यहाँ पे सर जो आपने बताया कि इंटरसेक्टिंग पॉइंट जो है आई मीन जेड एक्सिस जो है वो इट्स नॉट नेसेसरी दैट इट शुड बी एट द सेंटर
Yes
तो
beta.
सर फॉर एग्जांपल सर एक्स वाई एक्सिस जो है वो सेंटर में इंटरसेक्ट हो रहे हैं और जेड एक्सिस जो है हम लोग ले रहे हैं एकदम वाई एक्सिस लास्ट एज में सर तो
I'm
फिर भी
coming.
पैरेलल
I'm
एक्सिस थ्योरम एप्लीकेबल होगा सर
हाँ, I'm coming to that point बेटा. ठीक है, I will show you your question with the help of this. Actually, here we are going to deal with only those axes where symmetrical structures are created. So whatever your question is, I will give you a next example. I am coming to your question in the form of rectangular plate. ठीक है, when rectangular plate will be there, I will explain you what you are saying, whatever is your doubt, I will explain you in that detail. So here, try to understand. If you are rotating this disk about this z axis, then this will be iz. And how much is iz? Iz kitna hoga? That will be in the last class I have find out 1 by 2 mr square. ठीक है? If you consider x-axis here, if you consider this is x-axis, ठीक है? This is x-axis like this, and this is y-axis. ठीक है, this is y-axis. As I earlier told, if you rotate this disk about this axis, then you are going to have a symmetrical structure, sphere you are going to get. ठीक है, if you rotate this about the y-axis, again you will get the same type of symmetrical structure, sphere. So due to the symmetry, ठीक है, moment of inertia ix, it will be equal to iy. ठीक है, so due to the symmetry, ix will be equal to iy. So many things we have to learn how to defend them logically. So why ix and iy they are same? Because if you rotate either about x-axis or y-axis or any another axis that is passing through, which is acting as a diameter, ठीक है ना, diameter of the disk. So basically you are going to find out on rotating about all these axes, you will get same type of structure. That is spherical, sphere. So that's why they are equal. So Ix and Iy is, they are equal. Now apply perpendicular axis theorem. So apply perpendicular axis theorem. ठीक है? Perpendicular axis theorem. What it will be? Ix plus Iy equal to Iz. Iz. But you are saying Ix equal to Iy, so this will be 2 times Ix. And Iz, this is 1 by 2 mr square. So what will be Ix? Ix will be 1 by 4 mr square. 1 by 4 mr square. So Ix, Iy, they are equal and they will be equal to 1 by 4 mr square. It will be. ठीक है? Now suppose you want to find out, ठीक है? You want to find out the moment of inertia about this axis. Suppose this is x-axis and there is an axis here that is passing through this and parallel to it like this. This is the axis. This is parallel to x-axis and passing through this point. This is R. What is this? This is 90 degree here and this is R radius. You are rotating this disk about this. तो आप इसे ऐसे rotate कर रहे हो. What will be the moment of inertia? What will be the moment of inertia like this? So this axis, this is parallel to z-axis. Remember this. This is parallel to x-axis, not z-axis. This is parallel to x-axis. This is AB, you can say. Find the moment of inertia if you rotate this disk about this AB axis AB. Then you are going to use parallel axis theorem. Parallel axis theorem. If you are rotating about this, I'm saying this is IAB. What it is? This is IAB. तो कितना होगा बेटा? This will be IAB. So what it will be? IAB will be equal to IC. IC. This is the moment of inertia about an axis that is parallel to AB and passing through the center of mass. So this axis, x-axis. ठीक है ना? This will be x-axis plus mass of the disk and perpendicular distance between these two, that is R. So this will be mr square. This is going to be mr squared. तो ये कितना होगा? This will be mr square. Okay. Now this will be how much? IC कितना हुआ मेरा? बोलो बेटा. 1 by 4
by 4.
mr square plus mr square. And this will be 1 by 5. Skin of 5 by 4. This will be how much? This will be 5 by 4 mr square. 5 by 4 mr square. ठीक है? This is one thing. Second, consider an axis here. ठीक है? That is passing through this point. ठीक है? That is passing through this point, but that is perpendicular, that is parallel to z-axis. I'm considering this axis now. ठीक है? So this axis. This axis. ठीक है? This is z-axis. I can say this is z prime. This was x prime axis. This was x prime. So this is z prime axis. ठीक है ना? This will be z prime axis. This is x prime. This is z prime axis. Can you tell me what it will be? What is the perpendicular separation between these two z prime and z axis? That is r. R. So this you can write I. I can also write it as Ix prime. Ix prime I'm writing. This will be Iz prime. Iz prime will be Iz. Iz, this is also passing through the center of mass. So I can use this plus mass of the disk and R square. This is how much? This is 1 by 2 mr square plus mr square. Mr square. So how much it will be Iz prime? Iz prime will be 3 by 2 mr square. Mr square. ठीक है? Now consider this axis. ठीक है? This is x. I can consider, now consider this axis. Try to consider a new axis. I'm creating here this axis. Try to understand. I'm considering this axis that is passing through the center of mass. It is passing through this, and it is perpendicular. It is lying in the plane. Try to understand, it is lying in the plane. This is perpendicular to x prime and z prime. So what this axis will be, this is y prime. So if you rotate this about this axis, if you rotate this disk about this axis y prime, what will be iy prime? Can you tell me what will be iy prime? Bolo beta, this is what is this? This is a diameter. On rotating about this, you will get a sphere. So how much you are going to get? You will get 1 by 4. 1 by 4 mr square. Am I correct? भाई ये तो वही एक्सिस है ना,
Yes,
जैसे
sir.
एक्स एक्सिस है, वाई एक्सिस है, सिमिलरली दिस इज द एक्सिस. ठीक है, दिस विल बी नाउ अब फाइंड आउट दिस आई एक्स प्राइम प्लस
Sir,
आई. यस बेटा.
sir, here in order to calculate I y prime, we are considering at the point of intersection of z prime and y prime. X prime
Yes,
is also there, है ना?
yes beta, this is intersecting point. You can write it as O. I can write it as O. This is intersecting point. So I am considering third axis that is lying in the plane. ठीक है, passing through this intersecting point and perpendicular to x prime and z prime. So I have
Okay, sir.
created three perpendicular axis system again. Two are in the plane of the disk and z prime is perpendicular and they are intersecting at the same point. So I have again created three axis system. So now Ix prime is how much? 5 by 4 mr square plus this is Iy prime. This will be 1 by 4 mr square. So it will be how much? This will be 6 by 4. So this will be 3 by 2 mr square. So you can observe here that this Ix prime plus Iy prime, that is equal to Iz prime. Iz prime I have already calculated, that is 3 by 2 mr square. So that is equal to Iz prime. So you can observe here that it's not necessary that the intersecting point will be at the center of mass. ठीक है? It can be anywhere. It can be at this. Here you can choose it here. But what is important, that two of the axes, they should lie in the plane and they should be perpendicular to each other. Third axis will be mutually perpendicular to both. So all the three axes are mutually perpendicular to each other. Two of them are passing through the plane. One is perpendicular to the plane of the body and they are intersecting at a point. They are intersecting at a point on the surface of this. Okay? So it will be like this. So here, it's not necessary that intersecting point is the center of mass. It can be anywhere in the plane of the body. तो जो टू डायमेंशनल बॉडी है उसके प्लेन में कहीं भी हो सकता है. So you can apply this. ठीक है ना? This will be applicable. Now, so here we have applied both perpendicular axis theorem as well as parallel axis theorem. So this was a good exercise because both the theorems are applied here. Now, next. Uniform road. Consider a uniform road. Or before the uniform road, I want to tell you one more thing. Now, what you are saying that for the disk, ठीक है ना, for the disk, an axis that is passing through its center and perpendicular to the plane of the disk, if you rotate that disk about that axis, z axis, then moment of inertia is coming out to be 1 by 2. That is coming out to be, कितना आ रहा है? 1 by 2 आ रहा है. चलो, I will continue with disk first. Now try to understand. If you are having a cylinder like this, solid cylinder, I'm talking about solid cylinder first. This is solid cylinder. Solid cylinder. So you are having this solid cylinder. Its radius is r. length is L. Okay, its radius is R and length is L. And what you do, you are rotating this about this axis. You are rotating this about this axis. This is the axis of the cylinder, Z axis. And what we are doing, we are rotating it about this Z axis. So this is Z axis. Z axis. Now, what is the moment of inertia of this cylinder? Try to understand. You can consider that this cylinder is made up of large number of or infinite number of discs. This is one disc. Now this will be second disc. This will be third disc, like this. So it is made up of, you can say, if I consider this thickness very, very small, I'm considering this thickness infinitely small. Okay, so that this dimension is negligible, is negligible. So I can say that this solid cylinder is made up of large number of infinite number of discs. And we are rotating the cylinder about this Z axis. Then what will be the moment of inertia? So moment of inertia I of this disc, of this cylinder will be, right? This is the moment of inertia of this cylinder. First consider this one. First consider this disc. I'm considering this one, this disc. This is a disc. Suppose its mass is m1. I'm saying its mass is m1. Radius of this will be r. So radius कितना होगा? Radius for all the discs will be r. Radius तो r ही होना है. So what will the moment of inertia of this disc? That will be m1 r square and 1 by 2 will be there. 1 by 2 m1 r square. Now consider second disc. Now consider second disc. This one. Suppose its mass is m2. ठीक है, आप इक्वल भी कर सकते हो. Suppose this is m2. For the third, it will be m3. But for all the discs, height is negligible. ठीक है, we are consider. That's why I'm saying they are infinite in number. ठीक है, very very large number will be this. So for the second disc, it will be 1 by 2 m2 r square. For the third one, this will be 1 by 2 m3 r square. And this will continue. You are going to continue with this. Now what will be common here? Here 1 by 2 will be common. In bracket it will be m1 plus m2 plus m3. And it will go for all the disks which are involved here into r square. What will be this m1 plus m2 plus m3? That will be the mass of the cylinder. Suppose mass of the cylinder is m. Suppose mass of the cylinder is m. So what will be the moment of inertia of the cylinder about this z axis? That will be 1 by 2 mr square. So this will be the formula for the solid cylinder. Solid cylinder beta. ठीक है? And suppose this is okay for solid cylinder. This will be 1 by 2 mr square. Suppose you are having a hollow cylinder. Next, it may be a hollow cylinder.
एम आर स्क्वायर होगा फिर उसका.
ठीक है? Yes, beta. Hollow cylinder. Then hollow cylinder, you can consider it as made of large number of rings. Large number of rings. ठीक है ना? Large number of rings. You are going to place those large number of rings one above the another. ठीक है? This will be the first ring. This will be the second ring. This will be the third ring. Large number of rings. Rings of same radius. Of same radius r. Radius r. So in that case, this will be for the first ring. Suppose mass of that ring is m1. This will be r square. For the ring, what is the moment of inertia formula? That is mr square. Suppose mass of the first ring is m1 and r square. So this will be the moment of inertia of the first ring plus moment of inertia of the second ring plus moment of inertia of the third ring. And in this way, large number of rings are there. R square you can take common. So this will become M1 plus M2 plus M3 and so on. This will be R square. This is R square. R square. So this will be MR square. So this will be MR square. This will be for hollow cylinder. Okay? This will be for hollow cylinder. This is for solid cylinder. For solid cylinder is this, and for hollow cylinder this is. This is. Now next thing is, okay, is it okay with everyone? Is it clear?
Yes, sir.
Yes, sir.
Good. Next, one more thing you can do with the disk, that our disk is annular. We are having annular disk. This, and second is this. And this is the axis of rotation. You want to find out moment of inertia about this. Inner radius I'm saying is R1. Outer radius I'm saying is R2. So I am having a annular disk. ठीक है, मेरे पास कौन सा डिस्क है बेटा? ये annular disk है जैसे. Annular disk I'm having. This is the disk. ये वाला disk है. This type of disk I'm having. You want to find out the moment of inertia of the disk. ठीक है ना? This is your objective. Your objective is to find out the moment of inertia of this annular disk about this z-axis. This is called as annular disk. Plate or disk. It is like this. Now, how you are going to handle this type of problem? That's very simple. What you are going to do, you are saying कि mass of this is m. ठीक है, इसका mass कितना है? m है. ठीक है? Okay. ठीक है, no problem.
तो किसका मास है में एनुलर डिस्क का?
Annular disk का बेटा. ठीक है, annular disk का mass m. So how to handle? I'm not going only for this. I'm going to tell you a general methodology by which you can calculate any problem like this. It's not necessary here I'm saying this is annular disk, but this circular part, it can be anywhere. You can remove this part from anywhere from the disk. So what is the basic here? Try to understand. This is the complete disk. ये complete disk. And this is the axis of rotation. And you call it a z-axis. ये z-axis है मेरा. ये complete disk है. I am saying कि जो surface density है, surface mass density, in this type of question, you will handle the question in terms of surface mass density. ठीक है, sigma. So here I will write sigma. Sigma is mass per unit area. Mass per unit area. Later on, according to the question, you can find out sigma. Finally, you can substitute sigma there. You will find out the answer. Now this is a disk and I want to remove this part from here. I want to remove this part. So I can consider that this disk is made up of two parts. ये जो disk है ना, ये दो parts से मिलके बनी है. One, this inner part whose radius is R1. So I'm drawing here this inner part. This is the inner part. ठीक है? And this is the z-axis. Z-axis बेटा. This is radius is R1. This is R1 और ये जो पूरा डिस्क है इसका रेडियस कितना है? That is R2. Radius of this is R2. Outer radius is R2 plus plus this annular part. This is this part. This part. So this complete disk is made up of two parts. This is the axis, same axis. And suppose all the three, this disk is rotating about z-axis, this smaller disk is rotating about z-axis, this is rotating about z-axis. All the three, what is necessary? That all the three, ठीक है ना, complete disk, ठीक है, one part and second part, they are all rotating about the same axis. Now, tell me one thing. If you are having this axis of rotation, one particle is rotating on the circular path like this. This is M1. M1, you are rotating this about this with angular frequency omega about this. And you are having second particle. It is of mass M2. M2. This is also rotating about the same axis with the same angular velocity. What is the angular velocity? That will be same. Okay, their radius may be different. This radius may be different. Okay, so both are rotating about this. So what will be the moment of inertia of this complete system? ये जो पूरा system है made up of two particles, both are rotating in the same direction with same angular frequency about the same axis. So what will be the moment of inertia of the system? That will be I. It will be how much? This will be M1 R1 square plus M2 R2 square. So what you are learning from here, if you are having two objects and both are rotating with the same angular frequency about the same axis, then sum of these two, moment of inertia of these individual particles about this axis, sum of these two will be the moment of inertia of the system. ठीक है ना? Sum of these two moment of inertia is I1 and I2. This is suppose I1. This is I2. These are the moment of inertia about the z-axis for this particle M1 and M2. Sum of this will be equal to the moment of inertia of the complete system made up of two particles. Taken about the same axis. Same thing I am applying here. This complete system is made up of two parts. One part is this, one part is this. So if moment of inertia is I, okay, is I, then moment of inertia is suppose I1 plus moment of inertia is suppose I2. I2. So I can write I equal to I1 plus I2. But what is important here? In all the three complete system, part systems, they should have same axis of rotation. So you are going to find out these moment of inertia I1, I2 about the same axis. You can write here I, I1 and I2. Here I, I1 and I2 are about the same axis of rotation. Are, ठीक है ना, are about the same axis of rotation. ठीक है, axis of rotation is same, only then you can apply this. ठीक है, so I'm using this aspect. ठीक है, you can convert this with the help of radius of gyration problem. You can convert, you can create its equivalent where one particle will be rotating about the z-axis. You can create its equivalent particle system. ठीक है ना, where one particle will be rotating at the radius of gyration. So basically they are equivalent to point system also, particle system also, which are rotating about the same axis. And then you can apply this. So that's why I'm able to write I equal to I1 plus I2. That's
Sir?
why, yes, beta, please.
सर ऐसा भी केस हो सकता है जिसमें एक्सिस ऑफ रोटेशन ही वेरी कर रहा है, मतलब फिक्स नहीं है, एक्सिस ऑफ रोटेशन वेरी कर रहा है टाइम के साथ.
No, actually, what you are doing, you are applying this formula here. So here, ठीक है ना, here all the three axes should be same. Now, what is your question? Please tell me.
तो मैं पूछ रहा था, सपोज एक सिस्टम ऑफ पार्टिकल एक पर्टिकुलर एक्सिस में रोटेट कर रहा है लेकिन वो
Okay.
एक्सिस ही टाइम के साथ वेरी कर रहा है.
Yes,
मतलब
that is possible. That is called as body axes. ठीक है ना? Later on, we will two type of axis systems will be there. One is called as space axis system. Another is called as body axis system. ठीक है? जैसे cylinder है. Suppose with cylinder, I fix three. Suppose I am having this cylinder, this type of cylinder. Try to understand. This type of cylinder. मैंने थोड़ा तिरछा बनाया है इसे. ठीक है? So what I do, three wires, I choose three wires and I fix these three wires like this. One will be x-axis, this will be x-axis, another will be here somewhere here, that will be y-axis. ठीक है? x-axis, this will be y-axis, this will be z-axis. So three wires, ठीक है ना? I have fixed with this, with this body. So when this cylinder will move, when this cylinder will rotate, so if it is undergoing translational motion, then it is okay. But if it is translating as well as it is rotating, then try to understand all the three axes. They are going to rotate if you are observing from the earth. Suppose I am observing the rotation of this cylinder from the earth. Then these axes, they are going to vary with time. And these axes, they are called as body axis system. What you call them? Body axis system. तो जो आप problem बता रहे हो बेटा, that can be handled with the help of body axis system, ठीक है, and space axis system later on, ठीक है. और body axis system से आप space axis system you can move, and from you can transform from space axis system to body axis system with the help of rotational matrices, ठीक है ना, rotational matrices and Euler's angle. But later on, I will come to that later on. So come back to this. So now I am removing this part. I'm removing this. So what I'm writing here, I equal to just I equal to I1 plus I2. What is your objective? You want to find out for this. So you want to find out I2. So I2 will be equal to I minus I1. I कितना होगा? What is I? I is this. This is a full disk. Full disk के लिए क्या होता है? 1/2 into its mass. Mass कितना होगा? Sigma pi
Sure.
sigma pi r square. Sigma pi r square. This is the mass. ठीक है ना? This is mass. ठीक है. एरिया कितना है? pi r2 लिख लो बेटा इसे. Please write it as r2. So I should write it as r2. Pi r2 square. और ये कितना है? r1. और ये मुझे पता करना है. r2 square. तो ये 1/2 m r square. So this will be r2 square. This will be I. माइनस I1. I1 इसके लिए है बेटा. ये कितना होगा? माइनस 1/2 sigma. Sigma that will be pi r1 square. And that will be r1 square. So I have just applied the formula I equal to, ठीक है ना, 1/2 mr square in both cases. So what will be common here? 1/2 is common. This sigma is common. Pi is common. R2 to the power 4 minus R1 to the power 4. ठीक है ना? This should be I2. Now what will be sigma? Next thing is you can apply the formula of sigma. Sigma कितना होगा? You are saying the mass of this annular plate is m. ठीक है? So mass per unit area कितना होगा? What will the mass per unit area? Total mass of the annular disk divided by area of this annular part. कितना होगा area of the annular part? Pi r2 square
R2 minus
minus
R1.
r1 square. This will be, substitute that sigma here. ठीक है? Substitute that sigma here. So I will be, I कितना हो जाएगा? देखो I will be 1/2. ठीक है? This pi है. First I am writing pi, then sigma. Sigma is m divided by pi r2 square minus r1 square. This is sigma multiplied by r2 to the power 4 minus r1 to the power 4. ठीक है? तो pi will cancel out and you can factorize it. R2 square plus R1 square multiplied by r2 square minus r1 square. So this factor will cancel out. And what will be the moment of inertia of this? That will be I, 1 by 2, mass of it, r1 square plus r2 square. R2 square. This will be. This will be the formula for this annular disk. For annular disk, this will be the moment of inertia I. ठीक है? Is it okay? Next beta. ठीक है? Please note it down. So, if you are having an annular disk like this, half annular disk. This time I'm having half. This was asked in one of the exam. नेट में पूछा था शायद ये. I have discussed this aspect with you. So full annular disk was a planar structure, two-dimensional structure. So question was, suppose this inner radius is R1, this outer radius is R2, and mass of this half annular plate, जो half annular plate है ना, this is half annular plate बेटा. ठीक है, this is half annular plate. I want to find out the moment of inertia of this half annular plate. ठीक है, about this axis. Axis is this. This is my axis. This point is O, and this is Z axis. It is rotating like this. So on rotation, ठीक है, its mass is also given. Its mass is m. Try to understand. This is a 2D picture. This is a 2D diagram. This is half annular plate that is 2D in nature. If you are rotating it, what 2D structure it is formed? It is forming 2D structure, that is full annular disk. ठीक है ना, full annular disk it is. So formula for this, if you want to find out its moment of inertia about this axis, that will remain same. So what will be the moment of inertia? That will be 1 by 2m r1 square plus r2 square. So what I'm saying, it will have same formula, ठीक है ना, as it is for full disk. Why I am saying this? Remember this aspect is applicable only if this is a 2D structure on rotation. It is creating a 2D structure. Only the same formula aspect will be there. This concept will be there when a two-dimensional structure on rotation, it is creating a symmetrical two-dimensional structure. Then both structure, this half and this full disk, annular disk, they are going to have the same formula. If suppose you start rotating about this diameter, then you will create 3D structure. In that case, formula will be different. In that case, formula will be different. So don't confuse with this. Symmetrical structure will be formed if you are going to have this type of structure. ठीक है, hollow sphere, that will be a hollow sphere, but that is a 3D structure. So formula of 3D structure cannot be applicable for 2D structure. So formula for this is this one. For half annular plate, what you call it? You call it as half annular plate. Annular plate. ठीक है, so this is. चलिए बेटा, आज यहीं रुकते हैं. थैंक यू वेरी मच. नेक्स्ट क्लास में मिलते हैं. हाँ जी बेटा, बोलिए प्लीज.
प्रिंसिपल एक्सिस का एक बार डेफिनेशन बोल दीजिएगा.
बेटा अभी प्रिंसिपल एक्सिस नहीं इंट्रोड्यूस करते हैं. इन जस्ट कल छोड़ दो. वन मोर क्लास आई नीड, एंड आफ्टर दैट आई विल एक्सप्लेन यू प्रिंसिपल एक्सिस, प्रिंसिपल डायरेक्शंस, एवरीथिंग इन डिटेल. ठीक है, अभी उसमें नहीं जाते हैं, अदरवाइज वो कई बार कंफ्यूजिंग हो जाता है. ठीक है, बट वेरी सिंपल, यू कैन रिमेंबर इन दिस वे. इफ यू आर हैविंग ए प्रिंसिपल एक्सिस एंड यू आर रोटेटिंग द सिस्टम, ठीक है, whatever system is there, if you are rotating the system about the principal axis, you will have a symmetrical structure. ठीक है, mass distribution will be symmetrical on rotation. On rotation, mass distribution will be symmetrical about principal axis. If you want to write, you can write. अभी थोड़ा समझ आ भी गया होगा. So Principal axes are those axes about which distribution of mass will be symmetrical during rotation. Principal axes are those axes about which distribution of mass will remain symmetrical, will be symmetrical during rotation. I'm talking about during rotation. Underline this during rotation. ऐसा नहीं है कि you are not rotating and you are observing. During rotation, it should be symmetrical. It should create on rotation, it should create a symmetrical structure. So in class 11, 12, actually you are dealing with principal axes only. Most of the time you are dealing with principal axes. हाँ
Sir?
बेटा, yes बेटा, please.
Sir, please show previous slides.
Okay बेटा, just 1 second. This is the first one. This is the first one.
Yes, sir.
Second. This is second.
Yes, sir.
Then third.
Yes, sir.
This is fourth. Fifth.
Yes, sir.
This is fifth one. Then sixth one. 7. 8.
Sir, previous one.
Okay, just okay. This is 7th. This is 7.
Okay. Sir.
Then 8. Then 9. Oh, sorry, this is not there. 9. This is, I think, where is, this is 8th. यही था, मुझे लग रहा last था ये. This one was the last. Okay. I have not written any. Yes, beta, please.
Sir, I have a question on the perpendicular axis theorem.
बोलो बेटा, please.
Sir, can you please show the slide?
Okay. Which one? बता देना मुझे बेटा.
हाँ.
ये वाला? नहीं, इससे पहले होगा. I'm coming to that.
This one, this one.
This one? Okay.
No, no.
Next.
The next one.
Okay बेटा, बोल.
सर वो जो आई वाई प्राइम वो कैसे 1/4 m r² सर वो कैसे आया?
I y prime. देखो, look here.
Yeah.
ठीक है. I draw here. Suppose this is my disk. Suppose this is our disk. ये disk है बेटा. What is the moment of inertia about this axis?
IY.
1/4 mr square.
Yes.
1/4 mr square. If you choose another one, passing through the center, this is center, and you are rotating about this. It may be any, but passing through, it is like a diameter. If you are rotating the disk about the diameter, then it will be same, because you, in both cases, you are going to get the same sphere. On rotation, you are getting same sphere. So this will also be 1/4 mr square. Now consider this point. ये point इधर है कहीं. ठीक है? So this disk will be like this. ठीक है ना? It will be. I'm saying you are rotating about this. So this is also similar. They are all on rotating this disk about any of these axes. You are going to get a sphere during rotation. So about all the three axes, or you can create any another axis that is acting like a diameter along the diameter of the disk. ठीक है ना? You are going to have 1/4 mr square. This will be the value of moment of inertia. Either you rotate about this, rotate about this, rotate about this, or you can create any another. I can create this also. So about all these axes, ठीक है ना, moment of inertia will be 1/4 mr square. So ये क्या है बेटा? दिस लाइन, लुक एट दिस लाइन, ठीक है ना? दिस इज इन द प्लेन. ट्राई टू अंडरस्टैंड द पासिंग थ्रू सी, passing through this O. So this is lying in the plane, passing through the center. So this is a diameter. So you are rotating the disk about the diameter. So automatically this will be 1/4 mr square. ये वाला बेटा, वो मैंने गलती से सर्कल कर दिया. I y prime. This will be. Is it clear what I am saying?
Yes, sir. It's
ठीक है.
now clear.
ओके बेटा, गुड. हाँ जी बेटा, बोलिए प्लीज.
वो स्मॉल ऑसिलेशन का सर जो क्वेश्चन जो
बेटा वो मैं देता हूँ आपको, चिंता मत करो, भेजता हूँ. श्योर. चलिए,
Thank you, sir.
वेलकम बेटा,
Thank you, sir.
वेलकम
Thank
बेटा,
you, sir.
वेलकम बेटा.